Now in this part we will talk about division. The objective in division of radical expressions is that we cannot leave radicals in the denominator. Okay? So, no radicals in the denominator. Very important, because that will be the main objective of this part of the class. Now, to leave no radicals in the denominator, we're going to use a process that is called rationalizing the denominator. Rationalizing the denominator is very easy. We just eliminate the radical from the denominator. So let's apply some examples to see what happens or how we can achieve that situation. Example number 1. We have 15 divided by the square root of 5. So as you can see in here, we have a square root on the denominator. Then what it means is I need to eliminate this radical from here. So what I do is I'm going to copy the original expression, square root of 5, dividing 15. And what I'm going to do is create another expression that will not alter the process using the same radical. So I'm going to multiply and divide by a square root of 5. If you analyze, when I do this, I'm still dividing by a. I'm multiplying and dividing by an expression that is equivalent to 1. So I'm not changing my process. Therefore, what I have in here now is 15 square root of 5 divided by the square root of 25. Finally, we have 15 square root of 5 divided by 5. Okay, we've done the process. We finished the process of eliminating the radical from the denominator, and now what we need to do is just check the final expression. If this one can be simplified, we do it. If not, we leave it exactly as it is. And in this case, we see that 15 and 5, they have a common factor, which is 5. So I'm going to divide both expressions by 5. 15 divided by 5 is 3. The square root of 5 stays the same. And 5 divided by 5 becomes 1. And 1 in the denominator leaves me the expression like this. So as you can see, we have an expression that is in simplest radical form. We always need to keep that. And we eliminated the radical from that denominator, which was the main objective. Now let's analyze a second problem. Second problem involves a binomial in the numerator. We're going to have 3 minus square root of 5 divided by the square root of 3. Again, you see that the expression is divided by a radical number. So 3 minus the square root of 5 divided by the square root of 3, and I'm going to multiply and divide by an expression that is going to be equivalent to the denominator. So square root of 3 and square root of 3. This to keep up the balance in the equation. So what do we have in here now? On the bottom, as you saw in here, I'm going to omit the step of writing 25 or writing the square root of 9. And directly I'm going to write 3 because I know that the roots are going to get cancelled. Now on the numerator, I will apply my distributive property. So what I'm going to have is 3 square root of 5 minus the square root of 15. And in this case, that will be my final expression, because even though I can simplify 3 with 3, I cannot simplify the second element with this one. So it's not necessary to do all the process, so we just leave it as this section. So now we have the answer, 3 square root of 5 minus the square root of 15 divisible by 3. Okay? Another type of problem that we're going to do is the following. Number 3 from division will be 3 square root of 2 minus 2 square root of 3 divided by the square root of 3. So having this, I'm going to avoid repeating the expression again, so I know that I'm going to eliminate the radical by multiplying square root of 3 divided by 3 by the square root of 3, and then we proceed to apply the process. Therefore, here we have square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is 3. So I eliminate the radical directly. We apply the process on the top, and then we have 3 times 3 square root of 2 times the square root of 3 becomes 3 square root of 6. And the other one becomes negative 2 square root of 3 times the square root of 3 becomes 2 times the square root of 9, which finally will be simplified. So if you see, what we have in here is 3 square root of 6 minus 2 times 3, all divisible by 3. And as you can see, there is a common factor in here. So we're going to eliminate it. And my common factor is the number 3. So that means I can divide this expression by 3, and I can divide 6 by 3 also. Finally, the answer will be 3 divided by 3 will be 1. That means the square root of 6. And negative 6 divided by 3 will give me negative 2, giving me the final answer of the expression in simplest radical form. We will continue with some more examples. Now we proceed with the division of expressions that contains binomials with radicals in the denominator. This is a very special case because you cannot treat it like we did with the other, with the previous exercises, like examples number 3 and number 2. In here, we're going to have to deal with this expression. To eliminate this radical from the denominator, we're going to use something that is called the conjugate. The conjugate is an expression that will allow me to create a sum and difference pattern. And if you remember with multiplication, when we apply the sum and difference pattern to radical expressions, the radical got eliminated. So the objective will be this one. Now, the expression that is called the conjugate is simply like this. You change the symbol of operation right in the middle of the expression. So if I have in here a minus, then I change it for a plus. If in here I have a plus, then this one will be a minus. Only the operation symbol. If the values are negatives or positive, you leave them exactly the same. The only one changing is the operation symbol that we have in here. So we're going to proceed to multiply and divide by the conjugate, which is the value that is going to help me eliminate the radical from the denominator. So in here, I'm going to have this, and then the process goes the following way. As you can see, on the numerator, I have a distributive property. So I'm going to apply 12 plus 6 square root of 3. On the denominator, I'm going to have a sum and difference pattern. And the sum and difference pattern, if you remember, we eliminate it by copying this expression, this format. So what I'm going to do is I'm going to write the square of 2 minus the square of square root of 3. Sorry. Once we apply this, what we have is 12 plus 6 square root of 3. And on the bottom, remember what we're trying to do is eliminate that radical from the expression. This becomes a 4. And this becomes square root of 3 to the second power. Automatically, the root and the power cancels. So what we have is 3. Obviously, when you do the operation, what you have is 12 plus 6 square root of 3. And 4 minus 3, which is 1, so I'm not going to copy it because the expression, when you divide something by 1, is exactly the same expression. So if you remember, what we were trying to do was eliminate the radical from the denominator, which we did it by the sum and difference pattern. And this sum and difference pattern was a consequence of multiplying and dividing by what we call the conjugate. So very important that you keep in mind the process of the conjugate when you have a radical expression that is a binomial and that is in the denominator of a fraction. Let's fix up the idea with another example. Example number 5, a little bit more complex, or with more operations only. 3 square root of 5, square root of 2 plus the square root of 5, and on the bottom we're going to have 3 square root of 2 minus the square root of 5. People, one of the most common mistakes done by students is that they start canceling, and in here in between we have additions and subtractions. You cannot cancel if you have expressions like this. Remember, to apply the canceling process, we need to write everything as a multiplication. So in this case, we don't cancel directly as we usually do. We need our famous conjugate. And the conjugate of this expression, of this denominator that we have in here, is going to be 3 square root of 2 square root of 5. And since I have in here a minus, then I change it to a plus. That's my conjugate. You don't need to do anything else. Now, let's operate with the conjugate. 3 square root of 2 plus square root of 5. 3 square root of 2 plus square root of 5. And as you can see, we are not altering the expression. We are just trying to eliminate the radical. And here we come with another familiar situation. On the bottom, we have a difference of 2 squares. But on the top, my final product will be a perfect square trinomial. So I'm going to use this pattern, which is familiar to us from the section about polynomials. And we're going to apply it to do the part on the top, because they are exactly the same. So what I'm going to do is start operating. 3 square root of 2 to the second power plus 2 times 3 square root of 2 times the square root of 5 and add it to the square root of 5 to the second power. And at the bottom, we apply the sum and difference pattern, which is solved by the difference of 2 squares. So 3 square root of 2 to the second power minus the square root of 5 to the second power. And now, people, we have done the process of rationalizing the denominator, and what we need to do now is just simplify algebraically the expressions. So let's start the process. In here, we're going to have 3 to the second power, which is 9. The square root of 2 to the second power becomes multiplication by 2. We simplify all this expression. 2 times 3 becomes 6. And the square root of 2 and the square root of 5 becomes the square root of 10. And at the end, the square root of 5 to the second power eliminates the root. So what we have is 5. On the bottom, we have 9 times 2 minus 5. And if we keep on simplifying, 9 times 2 is 18, and 18 plus 5 is 23, plus 6, square root of 10. And on the bottom, what we have is 9 times 2, which is 18, and 18 minus 5 becomes 13. And if you see, what we have is an algebraic expression that is completely simplified and written in simplest radical form. That is the final answer. I hope that you have a nice time doing the division of radicals and rationalizing denominators. Good night.